this video, we're going to do notes for section 9.4, proportional parts and triangles. All right, our first theorem says that if a line is parallel, notice that by our little triangles right here. If a line is parallel to one side of a triangle and it intersects the other two sides, so it's intersecting at point B and point C there, then the triangle formed is similar to the original triangle. I'll go ahead and highlight the triangle. So we've got this small triangle then, triangle ABC, and it would be similar to triangle ADE. Okay, so I can put my sentences here, the triangles, the ones that I just did, and I'll highlight them again. I've got this blue triangle ABC and this red triangle ADE. So I'll write those similarity statements. So triangle ADE is similar to triangle ABC. Again, order does matter, so make sure you get those in the right spots. All right, an example here, we're going to complete the proportion. First thing I notice is that I'm given that this line VW is parallel to line RT, so I know that my triangles are going to be similar, and since they're similar, I can set up my proportion statements. So this first one says that SV is proportionate to the big triangle SR, and so the question mark, or I'm going to put an X over here, is what is similar to RT. So I've got that small side of the triangle, so this would be SV over SR is equal to VW over RT. So VW was that small side of that small triangle that was formed by those parallel lines. Okay. Moving on to our next example here. In the figure, JK is parallel to GH, so JK right here is parallel to GH. Because their lines are parallel, because those lines are parallel and it intersects on the sides of the triangles here at K and J, I know that those two triangles formed are similar. So I'm just going to write my similarity statement real quick. So I know triangle FJK is similar to triangle FGH. All right, so go ahead and set up our proportions. So I'm going to go 8 over this whole side, which is X, is equal to, I'm going to go with this small side 6 over this whole side, which if I add 6 plus 3 would be equal to 9. Go ahead and do our cross products to solve. So 8 times 9 is equal to 6x. 72 is equal to 6x. Divide both sides by 6. And I've got, pretty sure that's 72 divided by 6 is 12. So x is equal to 12. So the length of that large triangle side is 12. Okay. Moving on. Sorry about that. If a line is parallel to a side of the triangle, it intersects the two sides, then it separates those sides into proportional length. Sorry. Marker. So if a line is parallel, so this particular one line BC is parallel to DE, it separates the other two sides, so side AD and BC, or AD and AE into proportional sides. So I'll give you your proportional statements. So we've got AB, oops, I don't want the highlighter. AB over BD is going to equal to AC over CE. So the small sides of the triangles after being separated by those parallel lines in the middle are then proportional. Okay. Moving on to the next slide. Make this a little bigger for you. So using that theorem we just talked about, we know that if the lines are parallel, so right here I've got RS parallel to UV, I know that it separates my sides into proportional lengths. So I'm going to look at this first side here first, our VU. So I know that 4 over X is equal to, now I'm going to use this other side, VW, 5, oops, no, I don't want that, 5 over X plus 2. Looking to solve those, I'm going to use my cross products here. Remembering I'm going to put that quantity X plus 2 in parentheses, so 4 parentheses X plus 2 is equal to 5X. Using our algebra now to solve, I have to distribute first. 4x plus 8 equals 5x. I'm going to move this 4x to the right side here. So I've got 8 is equal to x. Only ask for the value of x, not the lengths of the sides. So x is my 8 is my x value. All right, looking at that second example here, again, we're going to use that theorem we just talked about, where if the two sides are parallel, I've got GH parallel to BC, then it separates the sides of my triangles into proportionate parts. Setting up my fractions then, I've got, oops, I don't want the highlighter, sorry, 3 over x, so this part over this part is equal to 4 over x plus 5. Working with cross products to solve now, so 3 times the quantity x plus 5 is equal to 4x. Using algebra now to distribute, 3x plus 15 is equal to 4x. Moving this 3x to the right side, I've got 15 is equal to x. All right, last example here, we're going to be finding the value of b. We are going to use that assumption that these are similar triangles. One thing that's missing here is that these two sides are parallel. We're going to go ahead and assume that to set up our proportion statements. I'm going to use the triangles that are formed are proportionate. So I am going to go with x. I'm going to call this x right here. Well, that's not a good spot to put that. I'll call this part x. So I'm going to go x over 25 is equal to, and that's going to be 6 plus x, because this whole side would be this small part here, plus that x, over this whole side over here, which is 25 plus 15, which is 40. Got my dead spot on my iPad, move that up, 40. All right, working with my cross products here, so 40x is equal to 25 times the quantity x plus 6, or 6 plus x. Let's fix that 5 here. So this is 25. So 40x equals, let's distribute here, so 25x plus 150. 150 moving this 25x over, I've got 15x equals 150. Last step then is to divide by 15. And I've got x is equal to 10. So x is equal to 10 doesn't give me what the value of b is. I need to make sure I say that b is equal to that 6 plus 10. So I know b is equal to 16. So we had to do that in 2 steps. We used that those 2 triangles were similar, set up our proportion statements, solved for x, then plug that x back in. All right, your homework then right now is that assignment number 6, where worksheet 9.4 is where you should be starting. Here we go.